Professor Ray here with another episode of Inventions that Changed the World, and today we're going to talk about the ruler. The ruler might seem boring at first, but measurements are critically important in the architecture, engineering, and construction industries. And the ruler is where it all started. As a matter of fact, we have some pretty advanced technologies today, such as total stations, digital photogrammetry, and 3D laser scanning, and we developed those because as technology changed, we needed to take measurements that originally were done with the ruler and do things faster, better, cheaper, and more accurately. So the ruler is where it all started. Interesting, the ruler fits into a field of a discipline called metrology. Metrology comes from the Greek word metron, meaning to measure, and ology, meaning the study of. So metrology is the study of measurements, and it applies to the ruler, it applies to total stations, digital photogrammetry, and laser scanning, just to name a few measurement techniques. So let's go ahead and get started. Before the ruler was invented, how did people measure things? As it turns out, they used body parts, and you may be familiar with one. It's called the cubit, and the cubit is a measure from the elbow to the tip of the middle finger. And for me, a cubit is roughly 18 inches. Cubit works great if everyone's the same size, but everyone is not the same size. If I measured, say, 4 cubits for an object, and someone who is a lot shorter than me measured, they may get 8 cubits. So they cannot compare the two measurements. They are radically different. So the cubit is not a great way to measure things. In the 6th century BC, there was a Greek architect named Theodorus of Samos, and he would be the first one to invent the ruler. And we think he's the first one. He was an architect, so it would make sense that someone like him would invent it because he was responsible for designing and constructing buildings, roads, bridges, aqueducts, things like that. The ruler would have been very important to accomplish all those things. But using body parts and, in some cases, rulers that may not be accurate, they were not repeatable, people had different size rulers that they had developed, there was a lot of inaccuracy, and it would be around 1196, King Richard I realized that the cubit and these other methods were just not accurate enough. So he came up with the idea of standardizing measurement, and he came up with the standard of the yardstick, which we have today. We have yardsticks, but the difference between his yardstick and our yardsticks is he made his out of iron. They were all manufactured and cut to the same length so that all the people who were using his standard were measuring to the same exact length. And that's critically important. As the fields of architecture, engineering, and construction advanced, all different kinds of measurement tools began to develop. But we always had this issue. We had to have some kind of standard by which we could judge them for their accuracy and their precision. As it turns out, in the STEAM subject areas, we use the SI units, or the metric system, and the standard unit of length in the metric system is called the meter. And here's the definition of the meter. The meter is the SI unit of length defined as the length of the path traveled by light in a vacuum during the time interval 1 over 299,792,458 of a second. And that seems like a strange number, but it's simply the reciprocal of the velocity of light in a vacuum. The velocity of light in a vacuum is 299,792,458 meters per second. So we have a very accurate and precise definition of what a meter is. Now today we have all kinds of rulers, and sometimes we call these scales. The words can be used interchangeably, so it's important to know that. You'll hear both terms. And for example, we have the typical ruler like you might use in elementary school. There are special rulers called scales, and this is an engineering scale, and it has different scale factors on each of the measurements on each side. We have steel scales, typically used by carpenters. Nice rigid scale, very well defined measurements. We have tape measures for making long measurements, again with a scale on it. We have folding rulers, another way to make measurements. There's all kinds of ways to make measurements using rulers. There are also measurements, devices made for special measurements, such as this device, which is used to measure the thickness of wire. In this case, the wire used to string a piano. We also have micrometers for making very small, high accuracy, high precision measurements, and we even have variations on a theme for different kinds of micrometers. We also have devices called feeler gauges that have thin pieces of metal, each with different thicknesses, and you can stack these up and use them to do things like set the spark gap on a spark plug on an internal combustion engine. Very important to be able to do that correctly. But there are other measurement techniques that have advanced as technology has advanced. One is the total station. It's basically a surveyor's transit, and you may see these mostly along highways where they're doing surveying. There'll be an operator behind a total station, and some distance away, and it can be a long distance away, is a person holding a rod that has a special target. That target is called a retroreflective target. So when the surveyor presses a button on his total station, it sends out a pulse of laser light. All those laser pulses go out, they hit the retroreflective target, and they come back exactly along the same path. And from that, knowing the speed of light in the air, we can make a direct measurement from the total station to that target. And that's how they do surveying along the highway for long distances. There's also digital photogrammetry, and that gets measurements out of digital images. So you have to know a couple of measurements to get started, but once you have those measurements, you can build a 3D model using things that are similar in both images, like edges of buildings, corners of buildings, different landmarks in all the different images. And I had an interesting application that I used that for one time. I was doing some work on a security system for the United Nations complex in New York City. I had a need for a three-dimensional model of the complex, and there were none to be found. So how did I do it? I took the free tour of the facility, and I counted my steps along the length and the width of the General Assembly building. Now, that's not super accurate, but for what I needed to do, it was plenty good enough. I then went down to the gift store, and I bought 5 postcards. I digitized the postcards and put them into a photogrammetry system. I used my 2 lengths to get started, and I created a 3-dimensional solution of the complex using those 2 measurements and those 5 postcards, and was able to build a reasonably decent 3-dimensional model, good enough for the purposes that I needed to do. I've also been heavily involved in 3-dimensional laser scanning, where laser pulses are sent out and they bounce off an object, and the distance to the object is made in 3 dimensions. These systems have become very fast, on the order of 1 million 3D points per second. So they can quickly 3D digitize some large area, and they're very accurate. In fact, at 300 feet away, the accuracy is plus or minus a 1/16 of an inch with some of these systems. So they can see a football field away, make a 1/16 of an inch measurement at 1 million 3D points per second. And from that, they can build 3-dimensional CAD models. Very, very interesting technology, very powerful, and gaining a lot of ground as far as where it's used today. Before I conclude this video, I want to talk about 2 terms, and I'm going to talk about these in future videos as well, because students often confuse these, and this is accuracy and precision. Accuracy is how close a measurement is to some known value. And in our measurements, how close to the meter would our measured meter be if we were measuring that way. So accuracy is how close to a known value. Precision is how repeatable are our measurements. So the best way to think of accuracy and precision is to think of a target, and say you're shooting a bow and arrow, and you're trying to shoot arrows and hit the bullseye of the target. There are 4 different things that can happen. You can have shots that are not accurate and not precise. They're scattered about. There's no rhyme or reason to how they actually hit the overall target. They're not near the bullseye. They're scattered around. You can have shots that cluster somewhat near the bullseye. Those would be accurate, but not necessarily precise because they're not very repeatable. They may be scattered, but it's better because they're all generally in the area of the bullseye. You can also then shoot and have shots that cluster very tightly together. They would be very precise and very repeatable, but they could be far away from the bullseye. So they're precise, but not accurate. In a perfect world, you'll have both. All of your shots will be very tightly clustered right around the bullseye. They will be both precise and accurate. Like I said, these are terms that students sometimes confuse, and it's important to know as you get into advanced science, technology, engineering, and mathematics classes, the relationship between accuracy and precision. And we'll touch more on that in future lectures. So I just really want to wrap things up by saying the ruler seems like a very simple device, very important device, and it has spawned the development of new devices as technology has advanced so that people can do all sorts of really cool measurements. They impact our lives every day. So the ruler really was an invention that changed the world. This is Professor Ray signing off for this episode.